Yes, student. Second type of reaction, after we have discussed the first type of reaction, it was nucleophilic substitution reaction. Now, the second type of reaction which are shown by alkyl halide is known as elimination reaction. Elimination reaction. Student, it is also one of the very important reaction. So what is it? We will check it. When alkyl halide are treated with alcoholic KOH, okay, alcoholic KOH, then elimination of hydrogen, okay, from beta position, that is beta carbon of carbon main chain. This is called what? Beta position. And halogen, okay, that is what? X from alpha position takes place. Alpha position takes place, forming alkene, okay, as major product. Student, here hydrogen is eliminated as well as halogen is also eliminated. Okay, that is elimination of two species from the alkyl halide takes place. Let me write it. See, this is a simple alkyl halide. This is X and this is what? H. What is this? Ethyl chloride. Isn't it? Plus, remember, alcoholic KOH must be there. Alcoholic KOH. Now, what is alcoholic KOH? KOH, that is potassium hydroxide, is a solid compound. We use its solution form, so we are preparing its solution by adding alcohol as a solvent. You know, alcohol, like water, act as good solvent. So if we add alcohol, then this KOH solution is known as alcoholic KOH. Okay, then on heating, it gives what? Alkene as a major product, that is C, double bond C. This is H2 and H2. So alkene is a major product. This one is alkene. Are you getting? Plus H and X simultaneously release out, that is eliminate. Now the carbon atom to which X is attached, this carbon atom is termed as alpha carbon, while the adjacent carbon atom, okay, is known as beta carbon. So the hydrogen gets eliminated from the beta carbon, while the X eliminate from the alpha carbon, and these two takes place simultaneously. That means what? The two species are eliminating, So we can write it. Eliminating means releasing. So D what? Hydro, that is hydrogen is eliminating. Therefore we can write D hydro. Along with halogen is also eliminate. Therefore called halogen. Okay, and the process is known as halogenation. Therefore this reaction is also termed as dehydrohalogenation reaction, or we can also term is beta elimination reaction. Now the main product obtained what? Ethene, or if you convert it any other alkene, then will called what? Alkene. Okay, so the alkene will be the main product. As you are increasing the carbon chain, according to it we can obtain what? Ethene. Now what about H and X? Whether they simultaneously react with each other? In fact what? No. In fact in alcoholic KOH there is what? ROH. Okay, ROH. And what about KOH? It produces K cation plus OH anion. That means what? The X, it reacts with what? K cation. Okay, and the H, it reacts with RO anion, forming again what? ROH plus what? KX. Isn't it? So this is about the reaction. Now why this happened? Okay, so here we have to check what? Mechanism. Okay, first step. What? Alcohol. I am directly writing, okay, without using word. ROH. Okay, on ionization produces RO anion plus H cation, isn't it? And KOH, it produces K cation and OH anion. Now student, the alkoxide ion form. Alkoxide, okay, ion act as strong base. Act as strong base which abstract proton. Okay, proton means what? H cation from, okay, what? Beta carbon of alkyl halide. Beta carbon of alkyl halide. Okay, while what? K cation, that is potassium cation, produced by its ionization. Okay, K cation abstract or eliminates what? X anion from alpha position. Okay, therefore the main product obtained is what? Ethene. That is what you can call alkene. Okay, I write here ethyl chloride. Therefore the main product is ethene. If it is any other alkyl halide, okay, and normal alkyl halide, in that condition the product will be corresponding alkene. Student, this is one of the very important reaction. Why? I will tell you by using one of the very important NCERT question. Okay. Yes, student, next one. I am not changing the heading. Elimination reaction or dehydrohalogenation reaction. Here, when alkyl halide. Now, which alkyl halide? Secondary alkyl halide. Okay, what is secondary alkyl halide? In which two beta carbons are present. This is called what? Secondary alkyl halide. Getting? Is treated with, okay, again same reactant, what? Alcoholic KOH, then an alkene is formed as major product which is highly substituted. That is more stable. Means what? Here there will be the choice. Okay, two types of alkene may be formed, but those will be the major product which is highly substituted, okay, or which is more stable. Now, in which sense and how can we explain its stability? So let's check it. So very first we have to change our compound. Say this is a compound. Here the X is attached here. So I told you this carbon atom is what? Secondary carbon. This one is primary, this one also secondary carbon, this one is primary. Okay, primary, this is secondary, again this is secondary, but this one is what? Primary carbon. Okay, when it reacts with alcoholic KOH, okay, now there are two options. The first option is the H can be released from right hand side beta carbon. Okay, that means if the reaction is in the reaction H and X, this one is getting eliminated, that is from the first position. This one our alpha, this one our beta. Then what? The elimination of hydrogen will take place from this position, means the compound will be what? Compound will be CH3, this is CH2, okay, and this is C and what? H, and this is C and this is H2. And now X released in the form of X anion, H released in the form of H cation. That means what? Now the bond pair of electron taken by X and it is given to this one. Thus there is what? Double bond is getting generated. This compound is known as what? But1-ene. Okay, so this is one of the options. The second option is what? Second option is if the H is eliminated from this beta position, then now the condition is what? Condition is elimination of H and X from here. So what will be the major product? What will be the product? CH3, CH, this one, then again CH, and there will remains what? CH3. But now the position of double bond will change. How it will change? It is CH3, no problem. But now from here and here, two species eliminates, therefore the double bond will come here. This compound is known as what? But2-ene. Getting? So the two compound, there is chances of formation of two compound. Now which compound is more stable out of this one and this one? We know, student, whenever reaction takes place, okay, the product form must be stable. If there are two choices, less stable and more stable, then the more stable will become the major one. Okay, we have already seen in Markovnikov's rule also. So one which is more stable will be the major one. So which one is more stable, but 1-in or but 2-in? Isn't it? Student, in 11th class, I explained you one thing. If there is an alkyl group, this alkyl group is considered as what? Electron releasing group. What? Consider it? Electron releasing group. And this is known as unsaturated system. Unsaturated system. Okay. The carbon atom directly attached with unsaturated system. This carbon atom is known as alpha carbon. In hyperconjugation effect, we have seen one thing. According to hyperconjugation effect, as many alpha hydrogens are present, that number of resonating, that is hyperconjugated resonating structures are formed. Isn't it? There is only one alpha carbon which consists 2 alpha hydrogen. That means it can produce 2 hyperconjugated structure. Isn't it? But focus here. Here the unsaturated system or conjugated system, this one, alkene, it directly attached with 2 carbon atom, one left side and one right side. Therefore, these 2 are known as alpha carbon and this one is also known as alpha carbon. And each alpha carbon further consists 3 hydrogen. It also consists 3 hydrogen. That means how many hyperconjugated structures are possible here? 3 plus 3 is equal to 6. According to the concept of hyperconjugation, as many hyperconjugated resonating structures are possible, more will be the stability. That means but 2-in is more stable as compared to but 1-in. Why? Because it produces 6 hyperconjugated structure. Okay? Therefore, we can explain. Okay? Why? So we can write the answer. It is because but 2-in, okay, have 2 alpha carbon, thus 6, okay, numbers of alpha hydrogen, hence forms what? 6 hyperconjugated structure. Okay, so it is more stable. Okay, while but 1-in, that is the first compound, have only 1 alpha carbon. Okay, thus 2 alpha hydrogen. So it forms only what? 2 hyperconjugated structure. Hyperconjugated structure. So is less stable. Student, therefore, repeatedly and frequently I am saying you that the 11th class concepts are very important. In the first chapter of organic chemistry of 11th class, we have studied about what? Hyperconjugation. So student, actually this phenomenon is explained by using what? Very important topic. This is called hyperconjugation. 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 So with the help of the hyperconjugation phenomenon, we can explain butadiene is more stable. Okay, student, one more very important thing. This is known as Set-Zep rule. This is termed as Set-Zep rule. Okay, I am writing here. This is known as Set-Zep rule. Set-Zep's rule. So what is Set-Zep rules? In case of formation of two type of protein by dehydrohalogenation reaction of alkyl halide, those alkene will be major product, okay, which will be highly substituted. Highly substituted means two alkyl groups are there, okay, and this is what only alkyl group is, one alkyl group is there, okay. So there are 1 plus I effect only, there are what 2 plus I effect, isn't it? But I explained this time on the basis of hyperconjugation. This question often asked in the example, what is Set-Zep's rule? So Set-Zep's rules applied in the case of two beta hydrogens are present, and therefore two types of product formation are possible. So the major product or the reaction will proceed by the formation of those alkene which is more substituted or which can give more number of hyperconjugated structures. Thus it will be more stable. Yes, student, now see the heading: elimination reaction versus substitution reaction. Okay. Elimination means removal of hydrogen and halogen from the alkyl halide, and the substitution means removal, that is substitution of only halogen atom, okay, in the form of nucleophile by another nucleophile. Such reaction is known as substitution reaction, isn't it? In first period we have checked substitution reaction, and today we checked elimination reaction. Now I am giving you one of the reaction of alkyl halide RX with KOH, but here only KOH is written. Which type of condition of solution is not given. So I am writing reaction between two compounds with different conditions. Say condition number A. Okay. When alkyl halide is heated with, now I am changing the condition, what? Alcoholic KOH, okay, then beta elimination takes place. Beta elimination reaction takes place. Okay, and formation of alkene. Formation of alkene, okay, takes place. Getting? You can write CH3, okay, and this is X, okay, and this is what? H, plus alcoholic KOH, we have discussed earlier, it forms what? ethene as a major product, isn't it? Plus Kx. Why? So because alcoholic KOH produces alkoxide ion. Okay, what is alkoxide ion? RONI is called alkoxide ion, which act as strong base. So it eliminates okay, proton. Now what is proton beta? This is what? H cation from beta position. Therefore elimination of H as well as X simultaneously takes place. Okay, but now the condition number 2. Okay, but when alkyl halide, that is say Rx, is heated with, now I am changing the condition. Besides of alcoholic, now I am writing aqueous KOH. What is aqueous KOH? The solution of KOH with water, aqueous KOH. Then substitution reaction takes place. Then substitution reaction takes place. Forming alcohol as major product. Forming what? Alcohol. Okay. Now, how it is? Say CH3, CH2, and this is X. Okay. Plus aqueous. Now what? KOH. So here the substitution takes place. Thus CH3, CH2, okay, and X is substituted by OH group, forming what? KX. Now why? Because H2O, okay, furnishes what? H cation plus OH anion. H cation plus OH anion. And KOH also produces K cation and OH anion. So concentration of OH anion increases. OH ion increases. Now student, if the concentration of OH anion in the product side will increase, then this increased concentration of OH anion, okay, furnished by KOH and water also, okay, will cause the substitution of X. Thus, the elimination versus substitution reaction in case of alcoholic KOH, alkene will be the major product and the elimination will take place. But in the case of aqueous KOH, alcohol will be the major product by substitution reaction. Which substitution reaction? Nucleophilic substitution reaction. Why it happens? It is because water furnishes OH anion, KOH also furnishes OH anion. The concentration of OH anion increases. Therefore, the nucleophilic substitution reaction takes place. Getting? This is also one of the very important question from NCERT book. Yes, student, the third type of reaction given by the alkyl halide is reaction of alkyl halide with metal. But which type of metal? Active metals. Active metals. Active metals means reactive metals, highly reactive metals like alkali metals, okay, or alkaline earth metal. They are called active metal like sodium and magnesium, okay, or potassium. They are called what? Active metal. So reaction of alkyl halide, okay, with metal. Here we can see one very important reaction through which we can form Grignard reagent. Student, Grignard reagent is one of the very important reagent. This is a versatile reagent and it has lot of industrial applications. Through this reagent we can produce large number of organic compound. So for that the scientist Grignard got even Nobel Prize for it. So what is Grignard reagent and how it is prepared? When alkyl halide, say Rx, is reacted with magnesium metal, especially magnesium metal, okay, in the presence of anhydrous and completely anhydrous ether, okay, that is the medium, that is the atmosphere of anhydrous ether is created during the reaction, and even the prepared Grignard reagent is also, okay, added with anhydrous ether. We will check why, okay, but first let me show reaction. So when alkyl halide is reacted with magnesium metal in the presence of anhydrous ether, then alkyl magnesium halide is formed. Okay, like I can write Rx plus Mg, okay, in presence of anhydrous, what? Ether. Okay, simply you can write diethyl ether, or this compound is called ether. Then R, Mg and X is produced. Like if I convert it C2H5, and this is what? Br plus Mg. In the same reaction condition it forms C2H5, okay, this is Mg and this is what? Br. Okay, this compound is known as Grignard reagent. What is this? Ethyl magnesium bromide or alkyl magnesium halide, called what? Grignard reagent. This is one of the very important reagent which is used to prepare large number of organic compound. Getting? Student, there should be even no traces of moisture, okay, while we are using Grignard reagent or preparing Grignard reagent. Now why? Student, if there will be hydrous condition or moisture, then you know that the active metal can react with moisture. Thus, first the Grignard reagent will not form, and even after formation of Grignard reagent, if there will be moisture, then this moisture will convert alkyl halide, okay, that is Grignard reagent, into alkane. Into what? Alkane. How it is? In case of moisture present, then what? R MgX will convert into what? Corresponding alkane. Okay, that which will reduce. Like, say this is what? R, Mg and X. Okay, plus if there is HOH, that is what? Moisture, then the R and H will combine, forming RH, plus there will be MgX and Br. MgX and what? OH. So now it converts into alkane. Therefore, there should be no moisture. That is, we have to use it in the atmosphere of dry ether. Usually, diethyl ether is used here. Second type of reaction, you know, in the 11th class, just before few days, we have read and discussed Wurtz reaction. Wurtz reaction. What is this? When alkyl halide is treated with especially which metal? Sodium metals. Okay, then alkane is formed. Okay, now the reaction is, that is, the product is completely changed. How it is? So remember, just 2 months before we have studied about it. You have to take like homework. Okay, and you have to prepare the described notes on Wurtz reaction. I am explaining the reaction when alkyl halide, okay, is reacted with sodium metal. I told you earlier, there should be 2 molecules of alkyl halide, and these 2 molecules must be of similar alkyl group. Like this could be CH3 and say Br plus 2Na plus BrCH3. That is, they must be similar alkyl halide. Okay, when treated with what? Sodium metal in the presence of again what? Dry ether. That is the same reaction condition. Okay, then these 2 NaX will combine and there will be R and R, that become alkane, plus 2 NaX. Similarly here there will be 2 NaBr and CH3 will combine together, forming what? Ethane, plus 2 Na what? Br. So ethane will be the major product. Now, why it happens? Okay, one question. What will happen if 2 different alkyl radicals are used? Okay, student, this is free radical reaction. Therefore, we are using similar alkyl halide. We have not to use dissimilar. One more limitation is there. Only alkane having even number of carbon atom can be prepared by Wurtz reaction. It is not applied to prepare the alkane having odd carbon atom, that is propene, pentene, septane cannot be prepared. We can prepare only ethane, butane and hexane. So the propane and pentane cannot be prepared by this reaction.